Players in the National Hockey League are celebrated for their speed, strength, and especially physical toughness. More than just amazing displays of athletic ability, every action and reaction that these superstars make on the ice follows the fundamental laws of physics, specifically Newton's 3 laws of motion.
Newton's laws of motion apply whenever something is moving, whether it's in the air, whether it's on the ground.
Sir Isaac Newton definitely did not have the NHL in mind when he published his laws in 1687. But the 3 laws of motion form the very basis for how objects move and react to forces applied to them, such as 2 NHL players colliding on the open ice.
Almost everything you do in hockey involves applying a force. When players collide with each other, they're applying forces on one another.
Robert Gertz is an astrophysicist at the University of Minnesota and has been supported by the National Science Foundation. In Newton's first law of motion, objects that are at rest stay at rest, and objects in motion stay in motion at a constant speed and in the same direction, unless acted upon by a force. The first law is also known as the law of inertia.
The inertia of an object remains the same unless a force acts. So if something is at rest, it will stay at rest unless a force acts. If it's moving, it will stay in motion in a constant way unless a force acts.
Consider a hockey player simply standing on the ice. He'll continue to stand still until something like an opposing player hits him with a body check. Jim Gates is a theoretical physicist at the University of Maryland and has also been supported by the National Science Foundation.
Imagine one hockey player is actually sort of looking elsewhere, and another hockey player comes up with a check behind him. He doesn't know it's coming.
Now, consider a scenario where a hockey player is moving in a straight line and at a constant speed. According to Newton's first law, the hockey player will continue to move in that direction and speed until acted upon by another force. Again, enter the opposing player.
The hockey player may have initially been skating directly in this direction, but after checking, goes off at an angle. He would have continued in that motion, except acted upon by an external agency, here being the checking player.
Even a hockey puck sliding across the ice follows this law.
If you watch the hockey puck moving with no one touching it, it goes in a straight line. If it was perfectly frictionless between the hockey puck and the ice, it would go on at the same speed forever.
In Newton's second law, if an object